And now we can derive the expressions. We have to derive the expressions for rise time, peak time, maximum peak overshoot, etc. Settling time, etc. So first we can find the derivation or expression for rise time. Expression for rise time, that is, as we all know, now we know that rise time is the time required for the time response to rise from 0% to 100% of its final value, because our we are considering the underdamped system. So it is the time required for the time response to rise from 0% to 100% of its final value. This is underdamped system. For overdamped system, that is just the time taken by the time response to rise from 10% to 90% of the final value, and it is denoted by TR. Now, we know that the final value of the step response is 1. Therefore, the rise time, that is 100% of final value. Therefore, the output is equal to 1. This expression we already derived in the last class. Output C of t is equal to, for a second order system, the output under damped system, the output is C of t is equal to 1 minus e raised to minus eta omega nt divided by root of 1 minus eta square into sine omega dt plus phi is equal to 1. That is general expression. Here we are going to find an expression for rise time. So replace t by tr. And the rise time, that is when t is equal to tr, the value of the response is equal to 1. That is the final value. CTR, final value is 1. From this expression, we can see that TR is equal to 1 to reach the final value. So we can equate this is equal to 1. So 1 and 1, it will get cancelled. Therefore, this term must be 1 minus some term is equal to 1. Therefore, this term must be equal to 0. And this term is not equal to 0. So what this term is not is equal to 0. Therefore, this term will be equal to 0. Sinusoid. So sine omega d tr plus phi is equal to 0. This term not equal to 0. So this term should be equal to 0. So that means sin theta is equal to 0 when theta is equal to 0, 2 pi, etc. And we have to take the acceptable solution as omega d tr plus phi is equal to pi. Take this is equal to, this angle is equal to pi. Then only we will get an expression. If it is equal to 0 means no. So omega d tr plus phi is equal to pi. And therefore, rise time is equal to TR is equal to pi minus phi by omega d. So you have to by heart this expression, we have to do problems. So rise time TR is equal to pi minus phi by omega d, where phi is equal to tan inverse root of 1 minus theta square by theta, and omega d is equal to omega n into root of 1 minus theta square. And by this phi, it should be in radians while doing problems. Pi 3.14 phi radians. So yeah, because omega radians per second, so you have to convert while doing problem all these angles to radians. That we can do in while doing the problem. Okay. So this is the expression for rise time TR, and you have to by heart this expression pi minus pi by omega d. So here this is the general expression for output of a response of an underdamped system, step input, step response of an underdamped system. This is equal to 1 when time t is equal to r, because it is by definition it is the time rise time is when it reaches the final value. So it is equal to 1. And so this term is equal to 0. This term not equal to 0. Therefore, this term is equal to 0. So sin theta is equal to 0 when theta is equal to this much. Therefore, take omega d tr plus y is equal to pi as acceptable solution. Therefore, rise time tr is equal to pi minus pi by omega d. So you have to by heart this derivation also and final expression. Important question. Similarly, next we can study, we can find an expression for peak time. Peak time. It is the time required for the time response to reach peak value for the first time. Peak value for the first time. It is denoted by TP. At T is equal to TP. In order to get the maximum value or peak value or maximum value, we have to differentiate with respect to TP and equate it to 0. So the response is this, and replace T by TP. We have to differentiate with respect to TP in order to get the peak value. So differentiate this. This term, it is equal to 0. Then minus sign. Here there is a minus sign. Then product two terms. So we have to first write this first term as it is. Then the differential of this second term, that is cos omega dt Tp plus pi into this omega d minus. One minus is there. Then write this term as such, sin omega d Tp plus pi, and here e raised to minus eta omega n Tp divided by root of 1 minus theta square into minus theta omega n. Equate it to 0 in order to get the peak value. So differentiate this expression with respect to Tp, equate it to 0, equate it to 0. Now this e raised to minus eta omega n Tp divided by root of 1 minus theta square, it will get cancelled. So minus omega d cos omega d Tp plus pi plus theta omega n. Theta omega n sin omega d Tp plus pi is equal to 0. This term, it will get cancelled, and write omega d is equal to, as we all know, omega d is equal to omega n into root of 1 minus theta square. So substitute that. Omega d is equal to omega d is equal to root of 1 omega n into root of 1 minus theta square. So omega n, it will get cancelled, then remaining root of 1 minus theta square. Cos omega dt plus pi theta sin omega dt plus pi is equal to 0, and we know root of 1 minus theta square, it is equal to sin phi, and theta is equal to cos phi from that triangle. Then rearranging and taking this expression, sin a minus b is equal to sin a cos b minus cos a sin b, you will get sin omega dtp is equal to 0. Or this is so we have to take it as equal to pi as an acceptable solution to get an acceptable solution. So omega d tp is equal to pi, omega d tp is equal to pi, or tp is equal to pi minus omega d. Omega d is equal to omega n into root of 1 minus theta square. Root of 1 minus theta square. Rise time is equal to pi minus phi. Here rise time. Peak time Tp is equal to pi minus omega d. Here what we have to do is, this is the general expression for time response for a second order system, underdamped system. In order to get the peak value, differentiate with respect to Tp and equate it to 0. Then simplify. Similar terms, it will get cancelled. Omega d is equal to omega n. Substitute that omega n. In this step, omega n, it will get cancelled. So root of 1 minus theta square and theta, instead of root of 1 minus theta square, write sin phi, theta cos phi. Then use this formula. Then you will get like this. So Tp is equal to pi by omega d. Now we find an expression for peak overshoot. Peak overshoot MP. It is defined as the deviation of the response at peak time from the final value. The difference between the first peak and the final value. Peak overshoot is the difference between the peak value and the final value. It is called maximum overshoot. That is, mathematically it can be expressed like this: CTP minus C infinity. CTP, peak value of the response. So at the time t is equal to Tp, the response is CTP is equal to 1 minus. Now substitute in order to get the value of the response. When we have to find MP, that is equal to CTP minus C infinite. steady state value that is equal to 1. But, so we have to calculate CTP. In order to get that, substitute the general expression like replace T by TP, and TP is equal to pi by omega D from the previous slide. TP is equal to pi by omega D. Substitute that. Pi by omega D. And again, omega D is equal to omega n into root of 1 minus theta square. So substitute for, first substitute TP is equal to pi by omega D in this expression. Then omega D is equal to root of omega n into root of 1 minus theta square. Omega n, it will get cancelled. It will get cancelled. So 1 minus e raised to minus theta pi by root of 1 minus theta square divided by this root of 1 minus theta square. Sine, again here also omega d into TP is equal to pi by omega d. So sine pi plus phi. Now sine pi plus phi is equal to minus sine. So this minus, it will become plus 1 plus e raised to minus theta pi by root of 1 minus theta square by root of 1 minus theta square sine phi. Now sine phi is equal to root of 1 minus theta square from that triangle. So again this 2, it will get cancelled. Therefore this is equal to 1 plus e raised to minus theta pi by root of 1 minus theta square. Therefore C of TP is equal to 1 plus e raised to minus theta pi by root of 1 minus theta square. And MP is equal to, what is MP? MP is equal to the difference between the peak value and the final value. Final value is 1. So the peak value now, it is obtained as 1 plus e raised to minus theta by root of 1 minus theta square minus 1 MP. Therefore, MP is equal to e raised to minus theta pi by root of 1 minus theta square. This is the expression. Usually it is expressed as percentage of peak overshoot, percentage MP, that's equal to e raised to minus theta pi by root of 1 minus theta square by C infinite. That is equal to 1 into 100%. So this is the final expression. Percentage MP is equal to e raised to minus theta pi by root of 1 minus theta square into 100%. Remember this expression, by heart this expression, it is required by doing problem. So this is the expression. MPC, percentage MP is equal to e raised to minus theta pi by root of 1 minus theta square into 100%. This is C infinite, that's equal to 1 final value. So here what we have to do is, this is the general expression. MP is the difference between these two. This is C infinite, that's equal to 1. So we have to find CTP. So substitute for TP is equal to pi by omega D. Pi by omega D in the expression. Pi by omega D in this expression. Then simplify. Then you will get this. So MP is equal to this term minus 1, C infinite minus 1. So this percentage like this. So this is the final expression. By head this expression, percentage MP is equal to E minus theta pi by root of 1 minus theta square into 100. And percentage of peak overshoot, percentage MP will decrease if the damping ratio theta increases from this expression.